So as I mentioned, we're really excited to welcome some researchers who are currently at Summit Station, Greenland, in Greenland. So Summit Station is one of the a year-round research station operated by the National Science Foundation. It's actually at the top of the Greenland ice sheet. So it's about 10,000 feet above sea level. It's a really unique place. And we have two researchers that are going to be talking to us today. We have got Murat Aydin, and he is a researcher at the University of California, Irvine. And we also have his colleague, John Patterson, who's also from the University of California, Irvine. And the two of them are spending a number of weeks up at Summit Station, and I am going to actually turn it over to John and Murat now, and they can take it away and tell us what they're up to. Okay. Oh no, did we lose them? That sometimes happens. Oh, they're coming back. There they are. Great timing. So as I mentioned, John and Murat are really at the top of the Greenland ice sheet. And so as always, you never know what's going to happen with technology. They're actually sitting in a tent. So I'm going to let them talk about that more. But John, you guys good?
Yeah, I think so.
Yeah, they're good
Fabulous.
for now.
All right. So yeah, like Sarah said, Murat and I are here at Summit Station in Greenland. We're drilling an ice core. So since this project is all about ice cores, I thought I'd start with some ice core basics. So ice cores come from ice sheets, and ice sheets form in places where it snows and it doesn't get warm enough for that snow to melt. So I have a little schematic here on the left. So how this works is when fresh snow falls, it's really light and fluffy, and that's because there's a lot of air mixed in with it. When more snow falls on top of that older snow, it starts to squeeze the older snow, and the older snow starts to densify. Now, as time goes on, that older snow gets buried deeper and deeper as it continues to snow, and it continues to get denser until ultimately it turns into ice. And at that point, any air that's still in that layer of snow gets trapped in tiny little ice bubbles. So ice core scientists get excited about this because we can drill down into ice sheets and pull up pieces of this old ice, and it contains samples of old air or the historical atmosphere. And we can learn a lot about the environment and the climate of the past by analyzing what's in these ice core samples. So I found this kind of neat graphic from the British Antarctic Survey that's on the right there. The timeline on the left is history, Antarctic history as recorded in books, and on the right is atmospheric history as recorded in an ice core. So there's a little too much there to go through right now, but I encourage you to go to the British Antarctic Survey website and check that out if you're interested. Okay, so just to give you an idea of the sort of data we can get from an ice core, this is a very famous plot of data from the Dome Sea ice core in Antarctica. And red on top here is global temperature, and in green on the bottom is atmospheric carbon dioxide concentration. So you can see over the last 400,000 years how CO2 and temperature have co-varied through several glacial cycles. So this is just an example of the type of information we can get from ice cores. And I'd be remiss if I didn't point out all the way on the far right there, the anthropogenic rise in carbon dioxide over the last couple of hundred years. Oops. Okay, so as I mentioned, we're here at Summit Station at the top of the Greenland ice sheet. So this has been the site of a lot of ice core drilling activities. In particular, this was where the famous GISP-2 ice core was drilled. So it took about 5 years to drill that ice core from 1989 to 1993. That ice core was about 3 kilometers deep, reaching the bedrock, and it was the deepest ice core ever drilled at the time. And the ice at the bottom of that ice core was dated to about 165,000 years. So this picture on the right is a picture of that GIST-2 ice core from almost 2,000 meters deep. And you can still see the annual layers really clearly here. So that's one reason that the GIST-2 ice core was so famous. It was one of the first ice cores where we had this really nice, undisturbed, whoops, stratigraphy and dating that deep in an ice core. So this project's also about atmospheric hydrogen. So I want to give you a little bit of background on atmospheric hydrogen. This is just a diagram of how hydrogen cycles in and out of the atmosphere. It's a little bit complicated for a 10-minute presentation, so I kind of picked 3 things that I want you all to try to remember here. So when there's more hydrogen in the atmosphere, there's more methane in the atmosphere. And that's important because methane is a strong greenhouse gas. It's really important for climate. Okay, so if there are any atmospheric chemists out there, hydrogen competes with methane for OH radicals, and that leads to an increase in the atmospheric lifetime of methane. If that sounded like gibberish to you, just remember when there's more hydrogen in the atmosphere, we're going to have more methane in the atmosphere as well. Item number 2 is one way hydrogen gets into the atmosphere is combustion, including fossil fuel combustion from humans. And lastly, I want you to remember that as hydrogen becomes a more important part of the energy sector, human emissions are going to increase dramatically. So what are we doing here? We are measuring hydrogen in a newly drilled ice core at Summit Station in order to reconstruct past atmospheric hydrogen levels. And we're doing that in order to try to investigate any possible feedbacks between atmospheric hydrogen and climate. And we're also trying to understand the natural variability in atmospheric hydrogen in an atmosphere that hasn't been affected by humans before we start to spew a bunch of hydrogen out into the atmosphere as part of the green energy sector. So this is a picture I took from our drill site just a couple of days ago. We'll be seeing a little bit more of that here. So what's been done before in terms of reconstructing atmospheric hydrogen levels? We've reconstructed hydrogen levels over the 20th century just by looking at the air in the densifying snowpack above an ice sheet. So it's a lot easier to get at that air than it is to get at the bubbles in the ice. So this is sort of a convenient way to reconstruct the atmosphere. And you can see over the 20th century, there was a pretty significant rise in atmospheric hydrogen, and that's associated with anthropogenic activity and fossil fuel burning. Now, it's convenient to study air in this densifying snow, but the problem is we can't go back very far. This only covers the 20th century. It doesn't get us to an atmosphere undisturbed by humans. So in order to get to an atmosphere that hasn't been disturbed by humans, we need to drill an ice core. But, whoops, too far. But no one's ever measured hydrogen in an ice core before. And the reason is it's pretty hard to do. So hydrogen's a really small molecule, so it can permeate through the ice much, much faster than other gases. And ice core bubbles are under a lot of pressure. They're being squeezed by the weight of all that ice that's sitting on top of them. So when you pull an ice core sample out of the ice sheet and remove that weight, all the hydrogen starts to spew out of the bubbles. So typically, ice core scientists bring their samples back to the lab to analyze them. But if we tried that for this project, all the hydrogen would have escaped the ice core already. So in order to avoid that problem, we've brought our instruments with us to the ice sheet. So this is just a picture of me in front of the instrumental setup. You'll be seeing a little bit more of that later in the event. But yeah, we're doing analytical chemistry in a tent. So as of a few days ago, we had drilled 150 meters deep, and our deepest sample The gas age was was from about the year 1730. So these black squares are new measurements we've made over the last couple of weeks, and I've left that history from our previous work here on the right. So that's where we were a few days ago. And this is where we're hoping to get by the end of the field season. So we're hoping to get to at least 400 meters deep in the ice sheet, and that should get us back almost 2,000 years ago. Yeah. So an awful lot goes into making a measurement of hydrogen in an ice core out here on the ice sheet. So instead of trying to give you one little piece live here, Murat and I have made a video where we tried to kind of take the whole process and show you some of the more exciting parts. And I guess before we head to that video, this picture I took just a couple of days ago, if you look really closely in there, you can see those teeny tiny bubbles that are filled with ancient air. Yeah, so with that, I think we can move on.
Fantastic. All right, let me pull that video up. Make sure we're starting at the top. So we're going to show this video that Murat and John made. Make sure I do it right. Share sounds. Okay. All right, we should be seeing it and hearing it, and we are off.
All right, done with breakfast. I'm here outside the big house, starting to walk out to our drill site. It's a little cold this morning. Wind chills, -13 Fahrenheit. So I'm kind of bundled up here. Yeah, here we go. All right, here we are at the drill site. On the left here is the brake tent. And then in the middle, the yellow tent with the gas tanks in front of it is the science tent. This first big white tent here is the tent where we're drilling. It's got the 700 drill in it, and there's some ice core boxes ready to be filled. And then the last big white tent is the 4-row tent. So we're gonna go ahead and get things started here in the drill tent with Murat, and let's see what's going on in there.
Okay, all right, we're putting the sand back down the hole now. We're gonna drill another meter. There goes the inner barrel.
Not easily. Okay. Make sure that that's.
All right. That was the middleman we're trying to fix.
Okay. That's good. Yes.
We're making sure the core logs are clear so we can break the next ice core. And Barb is cleaning the flights with the brush.
Basically gave them all like sports ball front tap, and they were like, "Put me in. I'm good."
All right. So the inner barrel gets attached. Now they're gonna push it into the outer barrel. now we're gonna raise the sawn. There you go. The winch pulls it up, and this clamp here, it's gonna roll down the rail, and then the sawn is gonna be vertical in a little bit.
Andrew, you gotta catch it.
I got you.
Alright, someone is actually positioning it over the hole. And now you can see the core cover down there as I unlatch it from the clamp. That's the borehole. Cover is open, and the sawn is going to go down to drill another meter of ice core.
Let's do.
Alright. That's it. As soon as the sawn disappears, we cover the borehole cover so nothing actually accidentally drops in there. That would be terrible for the drilling. Alright. We are bringing the drill up to fluid drilling. Just started the vacuum. Barb, what are we doing? Umberto there at the helm. This is our vacuum cleaner. We try to vacuum off the drill fluid that's on the cable so it doesn't drip all over the place in the tent. This is actually our ice core that was drilled during the previous run that's sitting on the table. When the next one comes up, we're gonna match it to the very end of this one, and hopefully it will just match up, and then we're gonna measure them together. Alright, the drill is out. The sound is coming out of the hole. We stop the vacuum. I gotta get out of the way so they can work. I'll try to shoot from the door. So the drill is gonna come up all the way to home position, and then they're gonna clamp it at the end of it and then lay it down horizontal. We'll see how that goes.
Because it was enforcing the slow speed super early.
Oh.
So I got banner.
We're not from.
Jay's drawing at the end of it right now.
So what is the... Okay.
There's an ice core sticking out of the end of it. So we're gonna have to slide it around the pan so we don't break the end of the ice core. You can actually see
Okay. Go down.
all right, now it's coming at us. I think the ice core sticking out will be more visible. So sometimes this happens. The core breaks a little deeper than where the core dogs are and sticks out of the barrel a little bit. We let the drill fluid drain. See, now the drill is horizontal.
Fingers clear.
Now we're gonna unlock the inner barrel from the outer barrel so we can pull out the inner barrel, transfer it to the left side where we're gonna try to push the core out. Alright, let me get out of the way. Here comes the inner barrel. It's full of chips, that's what you'd like to see. That means we drill a lot of ice. Those are the flights that push the chips up, the chips that we create. And this is basically the bottom of our core sticking out. We'll see the whole thing when it's laid out on the table. The barb is now transferring the inner barrel onto the left side. Now is the time to push the core out.
You can take your thumbs and try and push the core in.
All
See
right,
if you can break
I'm
it
just
to
changing
push in.
position so you can see it come out. Sometimes a push-up puts up a fight, but it is coming out.
Grab the pusher.
Grab the pusher. That's usually my job. I'm taking the video. For someone else is having to do my job, so they're struggling a little bit. Okay, now that's the core. It's the beautiful core right there. Congratulations to drillers. That's our little part of our water bottle that we're using as the middleman. Great core, great core. Yes.
Okay, here we are at the science tent. Let's head in. So nice vestibule here. Wood floor, a little bit of equipment, some plaza here. And then in here, this is where the magic happens. So this is what the science tent looks like when I get in the morning. Most of my instruments are in this big old insulated box that we built. So we're not supposed to run our generators at night. So so we keep our instruments in here to keep them nice and warm and cozy overnight. Keep everything plugged in to this big old battery pack that we charge off the generators during the day. So I've got a little bit of setup to do before we get started. I'm gonna go ahead and take care of that. Okay, so here we are all set up. This is the extraction side. So this is the side where we melt the ice core sample and get the old air out of it. And then we move that old air over to here. This is the gas chromatograph. So that's where we're actually measuring the amount of hydrogen in that old air. And this is my data computer. So we're pretty well set up here. It's time to go grab a sample and get to measuring. So let's go.
Smiley face. We're going to sample cores today.
Or heck yeah.
More cores.
All right, Murat and I are on our way to the
data points to the hockey stick.
Yeah, we're going down to the ice core storage trench here. We're gonna fill in a couple of blank spots in the data we have so far. So here's the ice core storage trench. You can see it's dug a few meters deep here with a nice plywood wall on the front. So we like to bury the ice cores a few meters deep because it's a little bit colder than at the surface during the summer here in Greenland. So let's head on in. So this is our storage area. I think we've got about 140 meters of ice core in these boxes right now. So we're gonna pick out a couple samples, cut them, take them back, and analyze.
You're willing to sacrifice our love. You want paradise, but someday you'll pay the price. I know, I've seen it before.
Okay, so we're back at the science tent with those two samples Murat and I just cut down in the trench. So we have one sample from about 83 meters. So the gas in that sample is from the year 1975 or so. And then we have one sample from about 134 meters. So the gas in there is from 1745 or thereabouts. So before we can take them inside and analyze them, we have a little bit of work to do outside. So we want to go ahead and clean the surface of these samples just to try to get any dirt or gunk from the drilling and processing that might be sitting on the surface. We want to get rid of that. And then these samples were drilled dry, but soon we're going to start using drilling fluid, a hydrocarbon drilling fluid, to compensate for the pressure as we go deeper. So it's going to be extra important that we clean the samples that have come into contact with that hydrocarbon fluid. So I've got a little cleaning station set up out here. On sunny days, I kind of have to move it around to try to keep it in the shade because I don't want my samples getting warm in the sun. So we're gonna sit down here and get to work. All right, so I've got a nice sharp scalpel here in my sample. So all I'm gonna do is just go ahead and start cutting away those top few millimeters, so we get to the clean ice underneath, just like that.
It happens all the time. You're closing the door, you leave the world behind. You're digging for gold, you're throwing away a fortune and feelings, but someday you'll pay.
Okay, here we are with a couple of nice clean samples. So we're about ready to take those into the tent and analyze them. But first, let's take a closer look at this deep one, the one from 134 meters. So if I hold it up to the sun here, let me see, there we go. So if you look closely, you can see those tiny little bubbles in there. So those are all full of that old air, the air we're interested in analyzing. So pretty cool that you can see them like that, I think. All right, so I have a couple of glass flasks here that I've been using to melt my samples. So I like to keep them cold by burying them in the snow outside. That way when I put my sample into them, it doesn't start melting immediately. Because if it, in that case, we'd start to lose some of that air. So here's one of my flasks. I have two of them. I'm gonna put it in this cooler that I've filled with cold snow. Put my sample right in here. And then I'm gonna take the whole package inside to the warm tent, so that way my sample stays nice and cold until I'm ready to melt it. All right, so here we are inside the tent. We've got our sample sealed inside our flask here and then hooked up to the extraction line. So if you kind of take a peek back here, you can see a bunch of different gas lines and valves it's connected to pressure gauges, which are up here, and also to our gas syringe, which is how we're going to move the air over to the gas chromatograph, and I'll show you that in a little bit. So the first thing we need to do is just pump all of the air that's in this flask away, because I sealed it up just in the atmosphere. So all I'm going to do now is open the flask to vacuum, and we should see this pressure come down here. All right, so now the only air that's still in our sample flask here is the air that's trapped inside our ice core sample. So now it's time to melt our sample, get that air out so we can analyze it. So I'm going to go ahead and close this valve here. So now we've isolated our melt flask from the rest of the line. And I can move the cooler away now because we're ready to melt. And now what I have here is just a little electric water heater that we're going to use to melt our sample. So I'm going to go ahead and move it up here, just like that. And now we wait. So here we are, sample's melted. It's liquid water in there, and all the gas that was in the bubbles is now free in the flask. So it's time to move that gas over to the gas chromatograph. So I'm gonna go ahead and expand my sample into the extraction line here. We should see the pressure come up. There it is. And now I'm gonna pull the sample into the gas syringe just by flicking this switch. There goes the syringe. It's starting to move, and the pressure is starting to come down a little bit as we're pulling the gas into that syringe. Okay, so now this gas syringe, this glass gas syringe, is full of our sample from our ice cores. So we're gonna now move it into the gas chromatograph. So I'm gonna flick this valve, and there's our gas chromatograph pressure. It's gonna come up a little bit. And now we're gonna compress the syringe. So all the gas that was in that syringe is gonna get pushed into the sample, into the gas chromatograph here. So you can see it start to move. Okay, so the syringe has finished compressing. And you can see that the pressure in the sample loop of the gas chromatograph has come up quite a lot. So now we're all set to go ahead and run our sample and find out how much hydrogen's in there. So I'm gonna click over to my software and just run it, and you should hear the valve turn. There it goes.
So I want to encourage all of our participants to please use the Q&A to put in any questions that you have, and we'll get started. I also do want to invite Eric Saltzman, who is joining us from California. There he is. To join us here for any of the questions that come up. And we can get started. Oh, people are starting to ask questions, and I'm glad they're asking questions that I have as well. So let's start kind of maybe with the process. Let's walk through the process. You showed us in the video, which was fabulous. And first thing obviously was getting the ice core. So how long does it take to get an ice core the size that you guys are collecting for this project?
Well, we measure the ice 1 meter at a time with this particular drill. And how much time it takes kind of depends. I mean, it ranged from we went as fast as like 12 minutes a meter. We had 12-minute runs. Sometimes we spend over half an hour, 45 minutes to, because the drilling is not really always the same. Every meter drill's a little different. So yeah, that's the range. So you can get anywhere from 3-4 meters in an hour to maybe just a meter in an hour. That's roughly it. And then we have to cut our sample. The sample we cut for Johnson Out is about like 10 centimeters long. So that gets cut separately and analyzed separately.
So you've got kind of this range. So you have your work day. How many meters do you try and get each day then?
What we try to get usually is we want to be above 20 meters a day. We had several days we did better than that. We had several days we did quite a bit worse than that. there are multiple reasons for it. I mean, the drill is sometimes it doesn't cooperate. It's a really finicky, very technical instrument. I mean, it's not an easy tool to operate. The drillers make it look easy, but um, so we're constantly trying to make things work and fix things and keep it operating. So some days go well, some days don't.
That's science, right?
Yeah.
That's field work. So, okay, so this is great. So you've collected your ice cores and you showed us where you save them. And then John, you get the cuts for your analysis. So how long is that process, right? So you show this, you cut it, you clean them, and then you did the melting and the moving and the gas transfer and everything. So how long would it take you generally to analyze one of these ice core samples?
Yeah, I think when everything's going well, I think I average about one sample per hour. I'm finding this is my first time doing field work. I'm learning a lot of the time things aren't going well. Yeah, so I on a regular day where everything's running smoothly, like 8 to 10 samples is pretty good. I've done a dozen. That was a kind of late night though. Yeah, so somewhere in there.
All right, that's not so bad. That's actually faster than I thought. So that's great. And then, okay, so we've done the analysis, which is fabulous, but as we saw, you only took kind of a few centimeters of the ice core. What happens with the rest of that core that you took? Does that get stored elsewhere? Does that travel for other analysis? You talked about how you have to do the hydrogen kind of at the site where you're going to lose it, but surely there are other gases and other analyses that can be done with those ice cores.
Yeah, so the vast majority of the ice we're drilling, I'm not analyzing here. So most of it is going to get flown back to the NSF Ice Core Storage Facility in Denver. So we have plans for some of it. So we're gonna resample at the depth similar, very close to what I've run here, and we're gonna try to assess how much hydrogen has come out of that ice over 6 months or a year or 2 years, and just kind of try to put some bounds on that question. But then ultimately, a lot of the ice core is going to be opened up to the sort of science community for whoever's interested.
Yeah, that's awesome. And I did see that we do have some folks from the Ice Core facility in Colorado on the call. So I'm sure they appreciate the shout out. And someone did ask about the data sets becoming available. And as you mentioned, the Ice Core community is an incredibly collaborative community. And so it's great to see how your work can then also be used by others in time. So this is a question that I always ask, or I always find fascinating also. Have you found anything else in an ice core that's not ice, shall we say? Or maybe you haven't gone deep enough for that.
Oh, you mean like a bedrock material or something like that? No, we're far. We've seen a couple of melt layers since we are in Greenland. Actually, Summit is normally a very cold place. And melt events are not that common, but they happen occasionally. So when we're drilling the core, we usually get excited when we see like something that doesn't quite look like the rest of the ice.
Mhm.
And we did see one actually particularly thick melt layer that a couple of bands that covered a few centimeters of like a 1 meter piece.
Mhm.
I don't remember off the top of my head the depth and the year of it. I'm sorry, but it was, I think, early in the 20th century.
Okay.
Because I think it was still, we were still in the fern ice somewhere. But beyond that, it's mostly ice. We haven't seen any ash layers or anything. So that's like something else that you could see, like from volcanic events, sometimes leave visible ash layers.
Yeah.
But the core so far, we're like not even at 200 meters yet. So we didn't see any such thing in this core. But you can see stuff like that in a deeper ice core, regular ice core.
Fabulous. And that actually brings us to a question that someone just asked, which is, you said you're not quite at 200 meters yet. It looks like you have a visitor.
You definitely did it.
Jay, do you want to say hi?
Welcome.
This is our head driller, Jay.
Jay Johnson here.
Awesome.
So they're
What are you
struggling to
drilling?
pull the core because the core table is full.
Yeah, we have the table full and another most of a meter waiting to come out.
Oh, so they
problem to
need. So how big is that court, actually, that drilling team? This is a great segue into that question.
Jay, so our project is, I think we have like 2 separate projects going on right now. So we have like 5 drillers.
5 total drillers, yeah.
But
Dedicated to this project.
3 of them dedicated to our project, and then 2 others are actually here to help out with a different project that are coming in and out of the tent. So we have like a circulating group of drillers. But JJ is in charge. He's like the actual superstar on the drilling side.
He's running the show.
He runs the drilling
The drilling
show,
side.
yes.
Well, it's awesome. We appreciate the work that you're doing because we're seeing this awesome science as a result. And we really appreciate it. What do you think is the kind of hardest part of doing the drilling process? Is it just the elements? Is it the materials? Is it things break and then you have to figure out how to fix it?
Yeah, and it's a brand new drill, so we're trying to debug and tune the drill while we're trying to run a science project at the same time. So wanting to try things and having to kind of balance that with, keeping production of the drilling going and keeping cores coming out. So that balance has probably been the trickiest, and having little struggles with the wet drilling portion, getting the drill to perform how we want it to. So trying to figure out what's going on.
Disappointed.
Well,
Okay.
they'll talk logistics about the drill
Yeah.
cores and everything. Awesome.
Right.
Well, we'll let you get back to work. We don't want to keep you from this important ice coring that we just saw an awesome video about. So you say you haven't quite made it to 200 meters, but how deep are you really hoping to go this season?
Wow. We don't want to make any promises.
No
Let's
promises.
say we want to go at least twice as what we drilled so far.
Okay.
Basically drilling projects, especially with a new drill, you have what you hope for, and then you have like what actually happens in reality.
Yeah.
And we'll see. I mean, I don't know. We hope to hit close to 400 meters.
That's awesome. That's fantastic. All right. Well, we're gonna wish you like positive drill vibes. I don't know if there's a patron saint of drilling, but I'm sure someone can tell us if there is. And I hope you get all of that. What I'd like to do also is find out a little bit more about what your life is like at Summit Station. So as we mentioned at the top, you're kind of at the top of the Greenland ice sheet. You're very high actually above sea level, which I think most people don't realize that the Greenland ice sheet's about 2 miles thick. So what is your life like kind of besides your work, right? You're working and you're living at the station. What do you do for meals and in free time, and what's that like for you guys?
Yeah, we have a chef here. So lunch and dinner are cooked for us, which is I would say I'm eating better here than I do at home generally. Um, let's see, free time. We haven't been swimming in free time so far. But I've gotten out and gotten to run down the skiway a couple times. We have a 5 kilometer long skiway where the C-130s land, which is the most memorable 10K I've ever run. Let's see, what else? Anything else?
We have a rec tent that we can, there's a little indoor workout space,
Yep.
so you can do that. We've done that a couple of times. Sometimes there are people pick movies. It's a
Mhm.
communal affair usually. There's like they announce that there's going to be a movie watching event tonight at 7:30 or something like that. If you wish to go there, you do that. Um, there are a lot of other science groups. Everyone's usually actually after dinner. There's some socializing.
Mhm.
There's a group of scientists. We just get on the computers. We start emailing and looking at data and stuff like that. And then there's some other groups of people. There's a lot of game playing is very popular. Like pastime after between the dinner until bedtime. People try to like squeeze in like a couple of board games, some card games. Cribbage tournament is like pretty standard. All color field camps, that kind of stuff. Yeah.
So no one's just binge watching Netflix. That's not gonna work. It's kind of before high-speed internet days.
Yeah, we could barely scrounge the bandwidth for the Zoom here.
All right, so anybody who wants to disconnect, Summit Station is a great place to do it. If you
Oh
don't
yes.
want to answer emails most of the day. Sounds like a good escape for some of us from our day, from our jobs. So you guys are up there. How much longer are you guys going to be up at Summit Station for?
3 weeks and a day. Today's actually the exact halfway marker.
All right, so you're about halfway. Okay. So when you leave, what does that look like? You have all these ice cores, do you pack them up and you bring them with you? Do they come later? Does, someone else come get your ice cores from the I say freezer, but it's really a snow
No,
igloo type thing.
I mean the plan right now is to ice will come out at the same time that we will. Um, Ice comes out on a what we call a cold deck flight. Essentially, a C-130 comes in, they don't turn the heat on, they fly the ice back. And we will hopefully be flying on a second plane on the same day for passengers. And then all the ice will from Summit go down to Kangar first,
Mhm.
Kangerlussuaq, which is like where the essentially entry point to the Greenland polar field research for US. And then over there, ice is going to be stored in a freezer for a while. And then that's going to be 19th of July.
Mhm.
And on the 25th of July, there is another cold deck flight scheduled, along with a second PAX flight, a passenger flight from Kangerlussuaq to New York. Uh, and then upstate New York. And then over there, ice gets taken out of the plane and then gets on freezer trucks. And then the freezer trucks will drive him to Denver to the National Science Foundation Ice Core facility. And it's going to wait there until we get to Denver sometime later in the summer or maybe in the fall. We're going to process it and basically make some measurements again and incorporate it into the Ice Core facility archive. That's the process.
Fantastic. Having made the drive from upstate New York to Denver, I know how long that can take. I'm just glad I'm not carrying ice core. I wasn't carrying ice cores when I did that. So that's fantastic. In kind of our last few minutes before we close out, I just want to give you an opportunity to share something that maybe hasn't come up that you want to leave this group with. Maybe it's something about the value of the work you're doing, just something that you think is really cool, that you want to share, really leave you with an opportunity for that.
To go. Sure. Um, let's see.
No pressure, no pressure.
Um, I would say, yeah, field work is super interesting and super challenging, and you can um plan and practice in the lab ad nauseum, and then you're all of a sudden you're in a tent and nothing makes sense, and yeah, yeah, it's been an adventure. It's been a lot of troubleshooting and a lot of work, but I think the data we're getting now is really pretty exciting. And I'm looking forward to, being able to analyze it. Yeah.
Yeah, I mean, I think I have a more experience than John in terms of field, but normally the drilling side itself is challenging enough. The fact that we try to incorporate science and do some real analytical chemistry, especially the type of measurements that he's trying to make here, I think it's a really big accomplishment for, and he's had a lot of success. The data he produced so far is really amazing. So I was not sure how it was going to work out, but
Well, it's great. It's awesome that you were able to try something new, and it sounds like it's going better than maybe you thought, despite all of the hiccups that always happen with any sort of science. I think we have a number of researchers on this call who's probably nodding along and understanding of that. So I do just want to close out for everybody with just a few slides, thanking you for joining. We actually do have another live event coming up. This is brand new. So save the date, July 16th, we're going to be boarding the US Coast Guard Cutter Healy with some of our researchers, and they're going to be talking through some of the work that they're doing in the Arctic Ocean. And so keep an eye out on your email. And then finally, obviously, if you want to learn more about the work that we're doing at NSF, you can follow us on social media. I'm also going to share in the follow-up email after this event, the social account for the university that John and Marat and Eric are all at, as well as additional resources, including information about the ice core facility that we've talked about, and more, some outreach materials, and a recording of this amazing event. So I want to thank everybody for joining us today. And in particular, I want to thank John and Marat, who took time out of their very busy, sounds like a schedule, to have this time and share their science with us. So thank you both so much. I'm going to hang on for a few minutes, and people can type if they have any last minute questions, and if not, then we're gonna close it out. So thank you all so much for joining us today.
thank you. I'm gonna start putting my clothes on, so get ready to get back to work.
Gotta bundle up before you go outside.